We're looking at one of your homework problems, which asks us to find the critical points for the following function f of x equals x times 16 minus x cubed. So to find the critical points, I need to figure out when is my derivative equal to 0, and are there any values which set my derivative or make it undefined. So we need to find the derivative of f of x, and as we look at the derivative of f of x, we're going to have to apply the product rule, and within that product rule, we're going to need to use the chain rule. And so the derivative of f of x the derivative of my first function x is 1 times my second function 16 minus x quantity cubed plus my first function, which is x, times the derivative of my second function. So let's bring down our power down front, 3. Of the inside, 16 minus x, subtract 1 from our exponent, which is 2, and now times the derivative of the inside. And the derivative of the inside is just -1. So I'm going to just rewrite this a little bit. So I have 16 minus x quantity cubed. So here I have -1 times 3, so that's -3, and -3 times this x. So we have minus 3x. All times 16 minus x quantity squared. So instead of expanding this out and then trying to factor, it's going to be easier if you notice that we have 16 minus x in common, and we can pull out 2 of those. So let's pull out a 16 minus x quantity squared. And so if we pull out a 16 minus x quantity squared from 16 minus x quantity cubed, we're left with one of them, 16 minus x. And then we pulled out this 16 minus x quantity squared from this -3x times that. So we're left with minus 3x. And so we have 16 minus x quantity squared. And in that second parentheses, let's just combine like terms. So we have 16 minus, well, -x minus 3x's, so minus 4x. I notice that I can pull out a 4 from that second parentheses. If I pull out a 4 from that second parentheses, I'm left with a 4 minus x, all times 16 minus x quantity squared. So set each factor equal to 0. 4 is never equal to 0. We're looking at when is 4 minus x equal to 0. Well, that's when x is 4. And we're looking at when is 16 minus x equal to 0. And that's when x is 16. So there's 2 values of x, which give us our critical values, x equals 4 and x equals 16. Okay, so another example from the homework. Suppose that at any given time, t, in seconds, the current I in amps in an alternating current circuit is I equals 5 cosine t plus 5 sine t. What is the peak current for the circuit, the largest magnitude? And so in order to find that, we're going to need to look at the derivative. And so let's look at the derivative of I. So I'm going to just call it di dt because we're taking the derivative of I with respect to t. So this is equal to, well, the derivative of 5 cosine t. Well, derivative of cosine is negative sine t. So this will be minus 5 sine t plus the derivative of 5 sine t is 5 cosine t. So we want to look at when is this equal to 0? When is negative 5 sine t plus 5 cosine t equal to 0? Another way to think of this is when is 5 cosine t equal to 5 sine t? Or when is cosine t equal to sine t? So I know that this is at t equals pi fourths. And they're also at, they're both negative in the third quadrant. So at 5 pi fourths. But this is periodic. And so pi fourths plus 2 pi. Or I can think of it at pi fourths plus pi gets me to 5 pi fourths. 5 pi fourths plus another pi will get me up to pi fourths. So we could write this as t equals pi fourths. Plus pi k. K equal to an integer. So this is what value of t, and it wants to know what is the absolute max. And so let's plug this in here. Actually, let's look at what is I of pi fourths. So this would be 5 cosine of pi fourths plus 5 sine of pi fourths. So this is 5 times root 2 over 2 plus 5 times root 2 over 2. So 5 root 2 over 2 plus 5 root 2 over 2, that's 10 root 2 over 2, which reduces down to 5 root 2. If I plug in, though, 5 pi fourths, that's going to be a minimum, because I would have 5 cosine of 5 pi fourths, but cosine of 5 pi fourths, we're in the third quadrant, cosine is negative root 2 over 2. Same thing with sine of 5 pi fourths. And so this is actually going to give me a minimum value, negative 5 root 2 over 2 minus 5 root 2 over 2. And so we have a maximum value when our the peak is going to be 5 root 2 over 5 root 2. Just pull it up. So let's just plug it in. So 5 square roots